Hello, thank you all for listening to ARC Advisory Group's Digital Transformation Viewpoints podcast. We explore all topics that impact industrial technology applications in their markets. Today, we're honored to have Cindy Crow joining us. Cindy is the industry principal in oil and gas for OSIsoft. OSIsoft supports the world's leading oil and gas companies, which I'm sure will lead to a great conversation today. Along with Cindy, we're joined by two ARC subject matter experts. Rick Riss. Rick is a senior consultant here at ARC. Rick is an expert process control engineer familiar with instruments, valves, analyzer, control algorithms, safety systems, software development, and project management. Rick has worked in chemical, oil, gas, power generation, including fossil and nuclear, power T&D, renewable energy, pharmaceuticals, paper, and building automation areas. The other senior analyst joining us from ARC is Tim Shea. Tim's focus areas include upstream oil and gas operational activities in support of digital oil field, including multi-phase flow metering, oil field operations management systems, artificial lift optimization, leak detection systems, drilling optimization, compressor and turbine monitoring and controls, and general field devices such as radar and ultrasonic level measurement devices, and pressure transmitters, among other areas. Rick, I'd love to hear your take now.
Great. Good morning, everyone. Thanks for this. With myself and Tim Shea will be asking questions today to Cindy Crow, and who's joining our conversation today from her Houston office. So let me just start by, as we're discussing this is the upstream market primarily, just over a month ago, the price of crude oil essentially collapsed. A number of factors were in play. COVID-19 was certainly amongst them, which had a large reduction in demand, but there were other factors as well. So that basically put the upstream and unconventional oil business into some pretty large-scale disruptions. So I want to start by asking my colleague Tim Shea his impression of where the market is going today, and have we recovered? And then we will be asking Cindy a number of questions about how the industry is adapting and some of the things going on in that industry. Tim, what are your impressions?
Well, thanks, Rick. Upstream oil and gas has traditionally been a very volatile segment of the oil and gas industry, whereas midstream is much more stable, and downstream does have some moments, but generally it's a little bit more stable now that it's matured. As you mentioned, the upstream oil and gas, the futures went negative there on the end of the contract. I think it was either from May or June. It was minus 37. I think it actually reached. We had certainly seen some historically low oil prices, and I think what's happened between the agreement that OPEC Plus, which includes Saudi Arabia, Russia, and other countries, to pull back production, as well as obviously the market impact of low oil prices in the North American markets, has helped to somewhat better stabilize the market. Now, obviously, oil prices are still relatively low. Futures contracts are trading in the low 40s as of today, the last I saw. So we're on the road to recovery, but I certainly think that the upstream oil and gas industry is going to have a lot of challenges for the next probably at least 12 to perhaps 24 months. We've seen bankruptcies and at least a handful of companies. The latest layoff count, I imagine we're probably getting close to at least 100,000 layoffs across various segments of the industry. So obviously it's tough times in the oil patch, as they say, but I do think that we're slowly starting to see some signs of recovery, but there's still a lot of challenges that remain in the future.
Great, Tim. I really appreciate your insight on that. Now, the first question I have for Cindy is related to an event we saw as a result in industry as a whole with COVID-19. So what I want to question is how engineering supervisors and managers suddenly were working from home, and how it was that they were able to effectively work from home and get the data they need. What special tools and capability exists that allow OSIsoft to make data available to home workers with the needed speed and security issues? Cindy, can you give us an input on how OSIsoft helped to enable this transition from a home work environment or to a home work environment?
Thank you, Rick. Certainly, remote access by our customers has been so critical to keep the operation running and safety at our forefront. The PI system and its ability to collect, analyze, visualize, and share these large amounts of high-fidelity data in real time help provide that information to operations, engineering, and management. Most of our PI servers are located in the facilities or near the wells themselves, so that gives them the ability to have the data in near real time, if not real time, based on their type of communication systems. By accessing some of this key data and insights about their operation, the PI system helps these companies deliver a greater operational improvement, look at their analytics and potential breakthroughs, and ultimately lead to comprehensive business transformation, even in the downtime. So I'd like to share an example with you. One of our customers, Petronas, is an offshore. Most of their operations are offshore, but they have an onshore engineering team that actually takes and analyzes the data and gives it back to operations in order to make corrective actions. Well, sometimes it was taking as much as 3 weeks for them to get that data. They'd have to physically go to the platform, get the data, bring it back to on-site, run their applications, and provide that corrective action. Well, because PI is near the operation, they were able to, once they installed PI, get that data immediately and within a few minutes design a corrective action and fix whatever was needed to be assessed at that time. So because it took that time, they were able to save millions of dollars in operating losses, but they've also been able to prevent 5 unplanned offshore shutdowns. In terms of security, the system allows for data monitoring, not system control, through PI. And therefore it's more secure by maintaining security between the process network and control network. Also, most of our customers are tapping into the power of the cloud and the analytics with the use of the PI integrator for business analytics, allowing them to have not only the data at their fingertips, but being able to get lots of historical data to compare the recent data to and provide much more granularity.
Oh, that's great, Cindy. Very interesting development that we've seen a lot of people with a lot of new adaptations to be able to work from home. So, Cindy, while it's my understanding that that drilling activities have slowed down significantly, there are still many related operations at sites where significant manpower, electric power, and chemicals are used. Producing wells are still producing. So let's start about applications that OSIsoft has seen that can track the location of people and vehicles to provide real-time GIS, graphical information system, tracking of these critical assets. Can you describe that?
Certainly. I think one of the things about drilling right now is while, when it's busy, drilling companies can't focus on optimization as easily as when there is a downtime. That being said, they can look at what they've done in the past and how they could do to improve in the future. They can do a lot of their maintenance during the downtime and things like that. One of the other key things is I'm going to describe a story to you that I think is, to me, one of the best stories, and that's Apache. Apache is using the PI system and an Esri integrator, which allows them for mapping and tracking of information. Apache has more than 19,000 wells covering thousands of miles. So with the PI system, they were able to create what they called these remote operations centers, which also not only handled drilling, but also operations. And one example that they shared with us was the fact that they had the objective to reduce downtime, increase response time, and improve safety. They wanted the ability to rationalize alarms that they were receiving on these wells and on these operations, on these pumps and things within the operation, but also to look at how they were allowing critical wells spaced over 5 million acres to be overseen without the way we used to do things was an operator had a route, and that route brought them, hundreds of miles a day per operator, but wasn't really necessary anymore because of all the automation we've been able to put into place. So with 25,000 miles of lease roads, putting the right person at the right location to eliminate whatever the issue that well was having was critical to them. So they used Esri and PI together to put the right people in that location. They were able to, if they needed assistance, look at a map and see what vehicle and what person was closest to that well, be able to run a Skype call, talk to that person and say, look, could you go check this out about this well, is, what needs to be done. Whether it was an electrician or an operator, whichever they needed, they could identify where they were and how close proximity they were to that well to go and look at it. So by doing this, they were able to minimize the amount of windshield time that people were spending and reduce hundreds of thousands of miles and be more safe in how they operated these fields. So whether it was drilling or operations, they were able to do this with the information from Pi and Esri.
That's a great explanation. I think that Tim now has a few questions for you.
Great.
As we all know, sites continue to use expensive electric power for pumps, lift pumps, compressors, and vapor recovery systems. Can you describe some of the ways that sites have been able to manage their electrical costs? We understand that some sites have sophisticated electrical metering, and have microgrids to provide even export power.
Yes, this is true. Many of the companies have been doing this for a long time, especially like in California where they have cogeneration. They've been selling to the grids for many, many years. So it's not really uncommon that we've been doing this. It's just newer to some of the other fields. So these days, with all that's going on, every cost is being looked at. So whether it be electrical cost or chemical costs or, manpower costs, all costs are being looked at because of the downturn in the industry. So some sites may, in terms of electrical consumption, have various pricing mechanisms because of the way the electricity is provided to that particular location. So some have intermittent day pricing, some loads are discretionary, so sites shift loads to use lower cost power in non-peak times, for example. Some companies actually are installing their own microgrids to ensure electricity and connectivity to their wells because of the uncertainty of electrical power getting to their fields. So where sites have a lot of artificial lift, electrical submersible pumps, and motors, there can be adjustments made to correct that phase angle to use power more efficiently. But a lot of these companies also use what they call pump-off control. What that means is where the well is only pumped, it's a well that's not making as much oil and is making a lot of water, for instance. So they only pump it a few hours a day to maximize the production and minimize the amount of water they're processing and lifting. This allows varying times for lower rate pricing and savings due to optimizing that power pumping time. Also, customers are looking at things like advanced mesh networks to reduce latency, increase data granularity, to be able to provide that data quicker to the field operations office or to the corporate office. This data transparency and security are vital for us as customers navigate the ever-changing energy landscape. And this data can only be unlocked with tools like this that simplify the complexities and interconnectivity. OSI Pi system continues to be part of that solution.
Great. That's very interesting. Operating sites continue to use chemicals for production to manage corrosion, biological growth, and to scale in the wells and flow lines, as well as separator and tanks for reducing emulsions. What types of applications have been used in OSIsoft to manage these chemicals and monitor the operation for cost control?
Yes, many of these applications have been looked at through OSIsoft Pi. We have success with monitoring all their types of different chemical programs. We have examples, whether it's an emulsion control for oil and water separation you mentioned, a corrosion application to protect the metallurgy of the downhole rods, tubing, or casing, scale inhibition for paraffin or hydrate control, all flow assurance issues that people have to pay attention to. So one example is with Pi is Chevron Frage in an FPSO off the coast of Brazil. One example that they shared with us is they use a defoamer for the high, medium, and low pressure separators. They have to do this because when that oil comes in, it comes in so quickly, it foams and therefore reduces the height available in these separators. So they reported a 5% savings in defoamer alone just from their one FPSO. So what they did is they created screens so that operations and engineering can share and monitor these chemicals, whether they're being delivered to the umbilical through to downhole or topsides. And all data is delivered on the Pi Vision screens to share amongst their team.
That's fascinating. The cost of an operating oil rig is in the range of $150,000 to $300,000 per day, and there are plenty of service companies that need to be on site during drilling operations. Delayed drilling operations are very expensive. What are some of the ways that rigs can be operated efficiently and reduce the overall cost of operation, and how does OSIsoft help with efficiency?
Sure. One example I'll share with you is from one of our customers, Marathon. They had several land drilling rigs that they were monitoring. And one of the key things is a lot of the land drilling rigs, because in the past people didn't keep the data from drilling rigs. They looked at it while they were going through the process of drilling, but afterwards they didn't really see a need for it. So with those rigs, they only had 20-second data. Well, when you're talking about the high rotating equipment of a drilling rig at the Kelly, or the rate of penetration that particular bit is turning, you need lower than 20-second granularity. You want something closer to 1-second granularity to pick up that vibration and understand issues like stick slip as the well is drilling and the bit gets stuck because it just continues to rotate and not make any downward progress. And this can only be understood at 1-second rates because the vibration data at 20-second looks very different than the vibration data at 1 second. So Pi can therefore look at these issues and help identify early ways that they can keep rigs from reaching a point of shutting in due to mechanical failure. And typically on these land rigs, mechanical failure or downtime in a rig is a killer for whether it be the contractor or the operator in terms of getting the wells completed. So customers have been able to do this and reduce the drilling times from spud to total depth by as much as 50%, saving millions of dollars. We've created a collection of OSI Pi vision screens which display all these issues such as hole depth, bit depth, rate of penetration, depth of cut, weight on bit, all the most critical parameters with drilling displayed real time and access both local and remote. This assists both the driller and the operator contracting them, but more importantly, it allows, as you're doing the drilling, a drilling engineer has many more applications than most other types of engineering in terms of determining these key pieces of information, and it truly helps them be able to maneuver the drilling operation as it completes.
Oh, that's amazing, Cindy. Really appreciate the discussion on all of the data that you're able to collect, in this oil field drilling application, and the speed at which you collect it as well is obviously important. It's pretty clear that one of OSI's strengths is the ability to collect data from a wide range of sources. DCS systems, PLCs, Internet of Things devices of every imaginable kind, and make that data available for monitoring and data analytics. With downtime in the industry, are there some unique ways that end users might be able to gather more data or extract more value from that data?
Sure, there are lots of ways to collect more data. One of the key things we see is, even though I spoke earlier about the operators and making their rounds, there's still a lot of companies using operators to make these rounds with a tally book. It's just, some people that's just how they do it. And I think it's by kind of collating a lot of that data that isn't being used, it gives a fuller picture of their operation. There's a lot of ways to collect more of that data. We talked earlier about collecting some of the electrical power data, which is a cost factor. We talked about the drilling data, which we just spoke of. Collecting data from LIMS, laboratory information systems, or other lab type samples and results are also critical. Collecting manually read data from these operators, from gauges or hand measurements, vibration data from rotating equipment, all can improve that operation and lead to effective ways to better understand it. Once you couple this data that I'm speaking of with the real-time data, collaborating all that information delivers much higher value analytics and much more value for the data that you're collecting. A spreadsheet or something sitting on someone's computer is not valuable unless it's turned in and used with the real-time data. So once you do that, using Pi as that data infrastructure allows many scientific models and applications to be used. So any of the applications that you would use help you understand how to better that operation and deliver near-time results through these additional applications. I worked for Schlumberger for 13 years, and this was one of the key things as I was constantly doing was connecting to Pi to run models for Olga for flow assurance engineering, or to run the Eclipse models for reservoir modeling. All these types of tools were things that I needed from Pi in order to improve the way in which I operated whatever system I was working on.
Oh, that's very interesting. The unconventional oil area, generally has much higher operating costs than conventional oil production does. And as a result of the pandemic and the lower prices for oil, it's important that these these end users are be able to extract value. Are there some unique ways that end users are able to extract value in this current market situation and continue to survive as an entity and make profit or improve their operation?
Sure, Rick. I think earlier to mention that there were over 100,000 jobs lost so far in the oil industry, and most of them upstream. Well, actually, most of them are in the unconventional space. So as you lose people, something's got to do the work. So having that remote access to data is a huge piece of that. So Pi has enabled the users to use that real-time operations data and actually enable the operators to do a lot of the work that was being done by some of the other colleagues before. So enabling these users to make that most effective economic decision and being more informed about which wells to turn on, which wells to turn off, which wells to go do maintenance on because they're not contributing as much to the overall production. So it's real money and a real impact, which wells to bring back onto production, which wells to keep off production, which assets to operate, to name a few. All these areas contribute to the total cost of operations and actually help keep these companies alive. Many of them now are facing bankruptcy, as you mentioned, and the only way they're going to get out of bankruptcy and get back to working is to make oil and to be able to sell it.
Yeah, that's obviously a pretty volatile situation. We know that OSI has participated with a large number of upstream and downstream, even midstream oil and gas partners. I'm sure that in that whole realm of experience that you have, that there may be some particular situations or use cases that maybe it did, in fact, achieve a very good evaluation, a very good value from the implementation of Pi. Can you give us an example of a use case?
Sure. Actually, it is in the unconventional space. One of my favorites is Devon Energy. Devon has achieved tremendous value from just two of the presentations that they made for us, that they've achieved over $100 million in value. The first was using our Pi asset framework to apply to their ESP systems. Most companies, when they buy ESPs, they source them from a variety of vendors. And they want to look at these and compare them to one another, but the vendors have different, parameters, different variables, things that they measure. So in order to look at these across the board, they put all their ESPs into one system and looked at the variables and determined which ESPs worked more effectively in their operations. They started by creating a new workflow and creating some predictive analytics and indication of forthcoming failures. Measuring key indicators, they achieved over $54 million in savings just on the ESP monitoring side of it. That's one piece. The second one is that they used Pi and Pi Vision to streamline their drilling engineering process, basically enabling multiple applications to be viewed through Pi Vision and reducing the number of days to drill and complete, saving Devon, again, over $50 million. Devon has used the Pi system extensively in a whole lot of different applications, but this is just two of their bigger ones. If you look on our website, you can see many of their presentations. But achieving over $104 million in just two applications, you can see how much return on that investment in Pi that they've achieved. So these and other customer stories are on our website if you'd like further details on what they've done specifically and how they've done it.
Well, thanks, Cindy. I personally have a lot of experience of extracting valuable data out of historical operations in refining, especially. And I think that today you've given us a lot of insight into some of the activities that are still going on in the upstream oil, and certainly would like to thank you and Tim for your very, very interesting and innovative discussions of how OSI and Pi is used to collect data and extract value out of that data. Thank you very much.
Thank you, Rick. It's been a pleasure.